Hi guys, welcome back. This is 3.4 part 1, the first of 3 videos. We're looking at Descartes' rule of signs. You just saw my pajama knee in there. Okay, we're looking at Descartes' rule of sign. By the way guys, this is a side note, but I'm giving you one version of things. I actually recommend that you look up different versions. So look up Descartes' rule of signs on YouTube or something and just see what other people are putting out. They have a lot of good instruction out there. I think it's kind of like when you're learning a language or any other thing, you want to get things in as many different mediums as you can, because then you kind of just immerse yourself in it. And really, math is a language anyway, so you want to just try to get it from as many different voices that you can. That's going to help it sink in better. But anyways, I'm just going to walk you guys through the actual questions rather than going through the theory. You've already seen the theory on the handout that I gave you, that I emailed you and posted on a resources page. Basically, we're looking at Descartes' rule of signs, and it tells you the number of sign changes is going to tell you how many positive real roots or negative real roots you have. For the positive case first, you look at the original f of x. Here, this is positive, right? Positive x cubed. Switching to negative, so that's one sign change. Stays negative, and then switch to positive, so that's two sign changes. Okay, so let's write that down. We have two sign changes. Okay, what that means is I'm going to have possibly two positive real roots, or the theorem says that number 2, subtracted by some even number. So 2 minus, the next one would be 2 minus 2, which is 0. Oh, sorry, I just saw my hairy armpit in there. Okay, so 2 or 0 positive real roots. Okay, and sorry for the clatter. Okay, let's look at the next part. So the next part of the theorem talks about the negative real roots. And for that one, what you use is f of negative x. Now, if I stick a negative x to my original function, it's going to turn odd powers the opposite sign, because negative x to the third power is negative x times negative x times negative x. That gives me negative x cubed, right? If I stick negative x in for x squared, though, it doesn't make a difference, because it's going to be negative x times negative x is, again, back to original positive x squared. So that one's going to stay the same, negative 2x squared. Now, when I stick a negative x here, negative 3 times negative x is actually a positive 3x. And 10, there's no x to speak of, so that just stays 10. All right, that's the negative case. Let's see how many sign changes that was. So I have starting from negative, nothing, staying negative, switch to positive, and that's it. So that means there's one sign change. That means one negative real root. And if I subtract 1 by 2, then I'm negative, so that doesn't make sense. So it's only one possibility. There's one negative real root. All right, so let's look at the possibilities together now, though, because remember the total number of roots or zeros. I've been using roots. I actually mean zeros, but basically the same thing like we talked about before. So let's be consistent with the language here, what's written on your paper. So I have two possible positive real roots or 0 and one negative real root. So let's look at the combinations, because I know my total number of roots should add to 3, right? Okay, so let's make a little table here. Let's do positive real roots, negative real roots, and then the last part that's going to fill things in is the complex roots. All right, so my possibilities. I could have 2 positive real roots. I know I have one negative one. That's already 3, so that's going to be no complex. Yeah. The other possibility is that I have 0 positive real roots. I already have my one negative one guaranteed. And then it needs to add to 3, so that's going to give me 2 complex roots. All right, so this is basically the answer here. These are the different possibilities for the root schemes that you can have, or the zeros. I've been saying roots again, but again, same thing. Okay, that's question number 1. Let's do question 2 and 3 in this video, and then we'll move on, okay? And, you have a video, so you can pause it anytime if you want to, like, I don't know, contemplate a question or something. Let me erase that whole thing. All right, let me look at what the next question is. I need to open up my computer here. Okay, this is a longer one. Oh, I'm sorry, my timer is going off. Oh, and you're hearing my background Netflix previews. Okay. Let's just move on. Number 2, this is f of x equals x to the 5th. Minus 3x to the 4th plus 3x cubed plus 2x squared minus 4x and minus 12. Okay, so long. All right, so let's count the sign changes first. So from this is a positive x to the 5th, right? Positive x to the 5th. Switching to negative, so that's 1. Then switch back to positive, that's 2. Then switch back to negative, that's 3. And so 3. We have 3 sign changes. Okay, that means I have either 3 or 0. Oh, I'm sorry. No, what am I talking about? 3 or 0. 3 or subtracted by even numbers. 3 or 1. Positive real roots. Okay, let's check the negative ones now. So this is looking at f of negative x. Now when I put a negative x for x to the 5th, that's going to give me negative x to the 5th. When I put it in for there, it's going to stay negative, so minus 3x to the 4th. This is going to be minus 3x to the 3rd, plus 2x squared, that stays the same, plus 4x minus 12. Basically all the odd powers of x switch signs, but the rest stay as they were. So here, starting negative, staying negative, staying negative. Here, switch to positive, that's 1. And then from positive, switch to negative, that's 2. So I've got 2 sign changes. Okay, it's 2 sign changes. That means we have either 2 or 0 negative real roots. Okay, this time I have to sum to a total of 5, right? Because my highest power is 5. I know there's 5 complex roots altogether. Complex meaning, well, 5 roots altogether. Complex plus real roots. Yeah? That's from the last class we did. Remember, last section, 3.3, part 2. Okay, so let's look at our possibilities this time. I'm kind of low on space, so I'm going to do it in 2 segments. Here we'll do positive real roots, negative, and then complex. Okay, you'll see the first set on the left. So I could have 3 positive real roots, right? And it's possible that I have 3 positive real roots and then 2 negative ones, right? In that case, that's already 5, so that's 0 complex. I could also have 3 positive and then have 0 negative, in which case that means there's 2 complex. Yeah, so that's another possibility. All right, I haven't done the possibilities when there's 1 positive real root, so I have to put that over here. So here's the other possibilities. I could have just 1 positive real root, and then I could have 2 negatives. That's 3, but I need a total of 5, so that means 2 complex. Or I could have 1 positive, I could have 0 negatives, which means I have to have 4 complex. Okay, so these are the 4 possibilities. 1, 2, 3, 4, those combinations of roots. And each of them, you notice, they add to 5, right? 1 plus 2 plus 2 is 5, 1 plus 4 is 5, 3 plus 2, 5, 3 plus 2, 5. Okay, that's question number 2. Let's move on to question number 3. Okay, open this thing up again. My computer just goes dark every time, so I gotta reopen it. F of x, 2x to the 4th minus x to the 3rd. This is number 3. 2x to the 4th minus x to the 3rd minus 3x squared minus 2x plus 8. Okay. Adjust this thing. I'll figure out a better way. I'll take it next time. Okay, so same thing. Let's count the changes. This is from positive to negative to positive, so there's 2 sign changes. All right, now let's look at f of negative x. The first part stays the same because it's even. This is going to switch to positive x to the third minus x squared plus 2x and then plus 8. Okay, so from positive, staying positive, negative, that's 1, back to positive, that's 2. So 2 sign changes. Okay, both of them have 2 sign changes. That means there's 2 or 0 positive real roots. And this is the same thing, 2 or 0 negative roots. Keep writing roots, sorry, zeros. All right, so let's look at the different possibilities together. We should have a total of 4, right? So let's do this: positive, negative, and complex. So I could have 2 positive, I could have 2 negative, that means there's already 4, so 0 complex. I could have 2 positive, 0 negative, that means there's 2 complex. Or I could have 0 positive, 2 negative, that means 2 complex. Or 0 positive, 0 negative, that means all 4 are complex. So those are the 4 different possibilities. That's it. Alright guys, we're finished with the first 3 questions. That one took a little time, but no big deal. Okay guys, see you in the next few questions.